All right, next up is freezing point depression. So as it says, solutes lower the freezing point. So this is the opposite for boiling. In boiling, gets elevated. In freezing, gets depressed. Try not to mix up the two. So one example of this is why they salt roads before it snows or ices. Wherever it gets that cold. Obviously, around us, it doesn't get that cold. But you toss some salt on the road in hopes of depressing that freezing point so it doesn't get cold enough to freeze, because that makes slippery roads. It's essentially the same equation as our boiling point elevation. So our change in the freezing point is equal to Kf, which again is just a constant, times the molal. The main difference, right, is that it's freezing point depression. So your final answer should actually be a lower value than your pure solvent, right? So it's the Tf of the pure minus Tf of the solution. You don't necessarily need to know this equation. You just need to know that when you take this value, you want to take your freezing point of your pure solvent and then take this value and subtract from it or subtract by it. Overall, these are just plug and chug type of questions. So check out your textbook for examples. Of course, the best kind of learning is active learning, so it's really best that you try to do this on your own. And again, think about, does your answer make sense? It's a freezing point depression, so make sure that the freezing point of your solution is lower than that of your pure solvent.